Welcome to another episode of RoboCNC. I'm Marcel. In the CNC router build we're doing, the RoboCNC X2 router, we're gonna do the x-axis with the rack and pinion style. I love to use ball screws, but if the length of the ball screw exceeds 1 meter, the chance of vibrations and wobbly shafts is quite big. So I'm gonna go with the rack and pinion. There are a lot of ways to go with a rack and pinion drive. The most rack and pinions I see is just a stepper motor with a reduction gear on it and one pinion in the rack. But if you do so, you can get a lot of backlash. So we want to use a backlash free system or get the backlash reduced to minimum. And to do so, we're going to use a product of Damen CNC. And this is the product altogether. So basically, you see we have two pinions. Two pinions are used to get all the backlash out of the rack and pinion system. We have a worm gear with the 1:10 reduction ratio. This is needed because the rotational speed of a stepper motor is quite high, so we need to reduce it in order to get a smooth, normal speed on the CNC machine. And of course, on the top we can mount our stepper motor. I want to show you this unit. We're gonna build one right now. And afterwards we're gonna test it, of course. I think the testing will not be in this video, but this is an assembly video. Hope you guys like it. Let's dive into it. In the package, first of all, we have the worm gear. You can choose which type you want. I've chosen the standard 1:10 ratio. So basically it's a 90-degree bend with a worm gear inside, and it's anti-backlash, so it should have really low backlash on the worm gear. Well, let's open up the package. We have a sensor inside. Some paperwork. Nice set of bolts. A tensioner, or all the parts that are needed for the tensioner, the belt tensioner. Some beautiful machined parts with the bearings already in there. A belt, some washers and some straight pins, a shaft, all kinds of goodies. Another great piece of machined aluminum. Some pinions, belt gears and some Tolux. BK61 Tolux. Well, and the last thing, the shaft. It has some fly rust on the shaft. I talked to the guys at Damen CNC, Kevin Damen, and they're gonna address that one. They're checking all their packaging and making sure these are greased, because this one is dry, which is not that great. Okay. So at the website of Damen CNC, there's a manual for assembly of this unit. But you of course have this video, so maybe you do not need it. So first of all, let's find step 1. An introduction and some tools required. Some Allen key, wrenches, etc, etc. An instruction for the bearings, to place the bearings and to glue them in place, applying Loctite, but it seems that the unit already comes with the bearings in place, so we do not need that one. Next step. Mounting the key in the primary axis. I've taken this down to the workshop and used some Scotch-Brite and some WD-40 to clean it up. If you have fly rust on it, it's easy to get it off, and if you do not have fly rust on it, you also need to go to the workshop because you need to get the grease off. Anyway, so make sure it's clean and put the key in there. Like so. So now we have the key inside of the shaft. We're gonna place the shaft inside the worm gear, making sure that we need a left unit and a right unit. So on one it needs to be inserted like this, on the other it needs to be inserted like this. In my case, I'm gonna place it like so. It's a nice fit. So with the shaft now in the worm gear, it's time to mount the RP cover. It should slide over the primary axis in this way that we have the most of this material on top of the worm gear. So this would be the wrong way. This is the right way. Next up, the tensioner. The tensioner is going to be used to tension the tooth, the timing belt inside this unit. So gonna put this one like so. I'm gonna place this bolt in here. The two bearings are going on this bolt and going to be mounted like so. There's a ring, nut, and a nut. Now we have, please focus, a tensioner like so. The next thing to do is make the secondary shaft. We're gonna take one tollock, and this tollock is used to clamp this gear pulley on this shaft. So I'm gonna loosen up these bolts. So that I can slide this on the shaft. Like so. Now I'm gonna take my calipers and set it to 8 millimeters. Or close to 8 millimeters is fine. I'm gonna make sure the tollock is about 8 millimeters. Oh. The tollock is about 8 millimeters from this end. So from here to here we have measured 8 millimeters. Now it's time to put the gear tooth on it, the gear pulley. I'll do it from this way, this side. Okay, so now I moved it. Not a big problem, gonna measure it again. Eight millimeters. There's this shim ring inside the kit. And I'm not sure where they used it for, but I talked to Kevin, and we do not need it for this assembly. But what I use it for now is to measure a small distance. So the tollock should be sticking out the pulley the same distance as the thickness of this ring, which is about 1 millimeter. And the reason I do that is that this will be placed on top of this bearing. And I only want the tollock to touch the bearing and not the pulley, because this would rub against the aluminum, and we don't want that. Simple as that. So from the tallock to the bottom it's 8 millimeters, and from the tallock to the pulley it's about 1. Now it's time to fasten the bolts, of course in a crosswise motion. So check it again. And it's great. Now I put the secondary shaft in its final position. And check it spins freely, which it does. So now the secondary shaft is in place in its final position. Now we need to make sure that the primary shaft is at the same, well, height in this case as the secondary shaft. The primary shaft can still slide up and down like so. So check if they are about the same height. Just by eye. And if they are at the same height, you're okay. So time to slide on the tallock of on the primary shaft, making sure that you do not slide the primary shaft anymore. The tallock is sitting on top of the inner race of this bearing, so the tallock can spin freely without touching the rest of the bearing. So this is the situation we want. Now we're going to use this spacer again and lay it down here at the bottom of the aluminum and put in the timing gear, the pulley. So the reason we do this is to make sure that this pulley and this pulley are at the same level, which is important, of course. Tighten the tallock. And don't forget to take the shim out. So that's that. In the next step, we're going to place the toothed belt, which is 90 XL. But to do so, we're going to remove the secondary shaft by trying to pull it out straight. Now we can place the tensioner inside the cover with the ring and the two nuts on the outside so it can slide freely. Taking the belt, putting it on the two pulleys, making sure the tensioner is loose, place the secondary shaft back in its final position. So we look like this. And as you can see, this will eventually be used as a belt tensioner. Oh. Oh, I need to do like so. This will be used as a belt tensioner later on. But I'm gonna put it like this. So, on top of each shaft, in the instruction manual, they say to put one of these rings. But I've been measuring the distance and the play that's in the shafts, and I found that it's precisely, if you follow these steps, it's precisely 2 of these rings before to put on this cover. So place the 2 rings or measure it for yourself and choose appropriate rings to get about 1/10 of a millimeter play, or just a little bit of play, but not too much. Okay, let's put this aside and work on this cover for a while. In the kit are provided 2 of these straight pins. And these pins will later on be used to align the rack and pinion to the CNC machine or to the rack. We need to put these pins in, but it's a real tight fit. So luckily they are threaded on one side. So I can take a bolt, put on some nuts and a ring, like so. And now I can tighten the bolt which pulls in this pin. It only has a short thread, so I have to place some more nuts on here and repeat these steps, or just take a hammer and try to tap it in. But make sure you start it like this, because you want it to be straight in the hole, after which you can use a hammer to tap it in. I'm gonna do this off camera, so stay with me. I'll be back with the pins in place. So the pins are in, just some light persuasion and of course military precision, but they're in and they're not sticking out on the inside, which is really important. And they are nicely straight and square with this piece. So time to put the cover on. Should slide on these shafts quite easily, or less I hope. Take the bolts. And still no friction, so the two rings are great, and I can minor play in the axial direction. It's really almost none, so that's really what we were looking for. So it's starting to look like something. Last step in this step is to put the remaining 4 washers, 2 on each shaft, which provides some clearance for the pinions to go on, which will be the next step. Next are the pinions to go on to the shafts. So we have 2 pinions with a large opening for the tallock. So we're gonna place the tallock inside, like so. Et voila. And we're going to make sure that the tallock is really loose, and then place it on the shaft. May even be somewhat more loose. So they can both spin freely on its shaft or on its tallock, doesn't matter. Now we're going to make sure that at the bottom here the tensioner is loose. These are loose. Now we're going to align them. And we're going to align them with a piece of rack. So this way we know that with a loose belt the tallocks and the pinions are straight in line with the rack, and now we can tighten the bolts of the tallocks. So basically we're done. As you can see, these pins are going to be used with feeler gauges and this rack to align the correct distance for the pinions to go. And then you will have play on the pinions and the rack. And that's correct, because you should have play. Between the rack and the pinion should be play. It's not a good thing to use a spring and tighten them together. That's not how gears work. What we're going to do is we're going to use these tensioners to tension the backlash, or with tensioning the belt and reducing the backlash to 0 in the rack and pinion, because we're gonna take this gear, rotate it like this gear, rotate it like this, and therefore this pulley will push on this side of a teeth, and this will push on that side of a teeth. And this is the way we're gonna play with this unit and reduce the backlash of the rack and pinion to 0. Still, there might be some backlash eventually in this worm gear, because worm gears do have a little bit of backlash, although I've tried to measure it now without any load on it, and it's really 0. I talked to Kevin from Damen CNC about it, and on high forces, when high forces are applied, it could have a little bit of backlash, radial backlash in the worm gear, but we're gonna see, we're gonna test out, and I think it's a great unit like so. Still, we have a few more pieces left over, so I'm gonna mount these. This one, again, great machining, great finish. What finish is this, Kevin? What do you use? What's your secret? Tell me. Okay. So, that's it. Now we have 2 rack and pinion units. You should have no parts left over, of course, except for the 2 shims, which were great to use to align the pulleys, and the sensor, which we will use later on in another video. Not sure if I'm gonna use this one, but we will see. We will be testing these units, and I will report back to you. Hope you liked the assembly video. If so, please hit the like button, give me a thumbs up, share it with your friends. Kevin, use it on your website and give me some discount next time. That's it for today. Thanks for watching. See you in next video.